P is invested at a fixed annual rate R, calculated at the end of each year, then the value of the investment after N years is A equals P times 1 plus R to the N power. Important things to know is what all those letters mean, because even if I give you formulas on the test, which I think I give you some formulas on the test, that's what I give you. I don't tell you what it's for. I don't tell you what the letters represent. So it's important that you know P is the principal amount invested, how much you start with. R is your interest rate. N is after N years. All right. A is the new amount that you get. So this first problem says, find the amount accumulated after investing a principal of $1,500 for 6 years at a 7% interest compounded annually, which means it's only once a year, which is why we can use this formula.
This isn't about this, but will we need to know what all the things stand for in heat problem 2?
And
The one we did 2 days ago on homework?
I don't.
The time and the temperature and all the keys.
I don't think that's on your test, but I'll check. Okay, Bradley.
That's a lot. Right?
We're gonna look at a. What did you say?
It's a one, right? I know.
Where's the one?
Never right.
1 plus R. This is compounded only once a year. In a minute, we're going to talk about a lot of things are compounded more than once a year. So we could change the formula a little bit if we're compounding more than just once a year. Like savings account, if you have a savings account that's compounded quarterly. I don't know, like actual things you invest money in, like IRAs. I don't know much about that, but I'm guessing more than once a year. But you've just got to plug all the stuff in. Definitely calculator heavy problems, which means I'll throw some calculators in a minute. But it's just plugging the things in and showing you that you can use your calculator correctly. So if I start with $1,500, right, this is saying we don't touch that $1,500 for 6 years at a 7% interest rate. We're going to say 1 plus 7%. R is always expressed as a decimal, so don't say 7 there, right? 7% is like 7 over 100 or 0.07. And it's compounded once a year for 6 years, so N is just 6. And you can type that all in at once in your calculator. You can do it a step at a time if you want. And you should get how much money they would have. Who needs calculator?
I'll catch a calculator.
Oh my gosh, stop intersecting calculators. Ready, Olivia?
I was going to say that without rocking right on my head.
Oh, I was a little off.
So, what are normal, like, actual, like, real life interest rates?
It just depends on what you're doing.
Having a bank account.
Savings account, your interest rate's really low, like under 1%. Like my savings account, it's like 0.025 or something. Like you don't get a lot of interest, which is why if you have a lot of money that you can invest, they want you to invest them in like IRAs and other CDs, things I don't really know much about, but they have a lot higher interest rates. Getting a loan, if you got a loan for a house, you could get anywhere from like a 3% if you have really good credit interest rate, or really bad credit, you could pay like 15%. So that's why it's important to have good credit, because the better credit you have, the better interest rate you get.
Better savings.
Yeah.
Good credit or bad credit?
What?
How do you have good credit or bad credit?
Right now, you guys probably have no credit because you don't have stuff in your name. But when you get credit cards or loans, as long as you pay your bill on time and you know like you're not late, you don't default on the loan, like you quit paying a loan, then you have a credit score. And so at some point in your life, it's important to obtain credit for yourself. So like, it's not a bad idea to get a credit card as long as you pay it off and you don't get in debt. And so you don't want to carry a lot of balances and stuff like that. So that's
one of your smart how to use good credit.
pay your bills.
So like I can get one now if I have a credit card, right?
Yeah.
I think my mom said that she wants to do that, but it's still not credit.
Yeah, it's a good idea. So we just typed this in our calculator, right? This is baby stuff here. To the 6th power, that's the little caret button. And we're rounding, we're talking about money here. So round to the nearest cent. And I would say that would round up to 10 cents. Agree with that? Did you get that? That's easy, right?
I was trying to figure out what the answer would be on my savings account right there while I'm doing that problem.
With my savings account, and I think he earns like 12 cents every quarter. So it's really not very much, but.
Gotta keep inserting money.
Okay, so here's the important thing. Most things are not compounded once a year. They're compounded monthly or quarterly or daily even. And so really the formula that we use more often is when we're talking about something being compounded k times a year. And so very similar to the last formula, except for we're going to throw in this k being the number of times a year it's compounded. And so now instead of just 1 plus r, we have to take 1 plus r divided by k. And if we're compounding it so many times a year, we're going to do that to the kt power, or kn power, the last one we used n, I guess. But k, it says that up here, I'm going to write it down here. K is the number of times a year that it's compounded. Everything else is the same. The P is the principal, R is the interest rate, T or N, whatever you want to use, is the number of times a year that it's compounded. And then you can do this for any type of problem that's compounded more than once. Again, this is only true for things that you're not touching. So like a savings account that you put money in, but you also take money out of, this doesn't apply to it because this would be like if you don't touch this money for this amount of time. So more similar to like a CD or IRA, because I think you're not allowed to touch that money for so many years. You do like a 5-year or 10-year CD. So
Can you put money into a savings account though and not have it affected? Or do you
well, if you put money in it, then it's going to be more money over time, right? And we actually have a formula on Monday I'm going to give you that would show that. Like if you deposit so much money, like I have a retirement account, so every time I get paid, I put so much money in that retirement account. Plus it's earning interest and all this stuff. And so there's a formula for that as well, like a different formula, a crazy formula. But now look at this. It says, find the amount accumulated after investing in principal of $1,500 for 6 years at an interest rate of 7%. Same problem we just did, except for now we're compounding 4 times a year. And oftentimes that will be said quarterly. Quarterly means 4. Quarter or something. 4 quarters, $1, because it's 1 quarter, $1. 15 minutes is quarter past the hour, is 15 over 60. 1 quarter.
Yeah, fractions.
So same thing, except now I'm going to take 0.07 divided by 4, and now my exponent is 4 times 6. If you're typing this all at once in your calculator, very important that you use correct parentheses, because if you raise that to the power of 4, and then you multiply by 6 without parentheses, you're going to get a very wrong answer, because your calculator will do the power of 4 and then take the whole thing times 6. Or you could just say in your head, 4 times 6 is 24, and just take it to the 24th power and not have to worry about it. But again, part of the test is knowing how to use your calculator, which is why I keep trying to make you use the calculator in class. 0.07 divided by 4 raised to the 24th power. I got $2,274.66. Which is a little bit more money than the last one.
That's what I got.
Type it on one side. Go. Do it. Do it. Times. It should parentheses.
Plus, parentheses, 0.07.
Whatever you use.
Oh, what? Crap.
Anyone else need calculator help?
Divided by 4, parentheses. Yeah, I got it that time.
Okay, anybody else need help with this? Alright, one more formula today. So, I feel like I could have just started with this one, but this is kind of summing it all up. So if you have a principal invested at a fixed annual rate, then the value of the investment after T years, you have one of 2 options. One is what we just did. If it's compounded K times per year, we're just going to write it again. A equals P times 1 plus R over K to the K T power. But we also have something called continuously compounded interest, and I don't really know E, R is your interest rate, T is time. We don't have to worry about how many times a year because it's continuously compounded. And so E takes care of that. So when you do these problems today, some of them are just plugging things in your calculator, and then in a minute we're going to do the other part, the pre-calculus part of it. But you have to make sure you read how it's compounded. If it's compounded so many times a year, even if it was only compounded once a year, like if you plug 1 in for K, you get our first formula, you use this one. But if it says compounded continuously, then that's the key that you know to use first. And again, you're just going to use your calculator to do that. So the R and the T are both in the exponent, so again, important that you do that correctly. And so this one we should have done the same problem again, so we could see how much money difference it is coming to. So that's right. 1250 e to the RT power. And so 5.4%, don't forget to make that a decimal. Move it back 2 places, so that's 0.054 times the number of years, which is 6. And again, you're just typing that in your calculator, getting the answer. And when I hit E on my calculator, it automatically gives me the exponent. I got 1,728.31 cents. I have it on my paper. I don't know why I'm typing it back in my calculator.
Yeah.
You got $480.
And this is how easy
It doesn't seem like very much, right? I know. Okay, so that's pretty easy. If you know what formula to use, you just plug numbers in. So obviously, this is pre-calculus, or a whole homework can't be that easy, right? And so because we can solve ln and logarithmic and e equations now, we're going to be solving for other things. So what if they tell me how much money is there, and they ask me to find how long would it take to get this much money, or what if they ask me to solve for the interest rate? And so they're going to give you problems that you have to plug in what they give you, and then solve for what's missing. Sometimes you're going to end up lning both sides, or logging both sides. And so let's do a couple of those. And again, I printed these out for you because they're very long problems. If Joelle invests $8,000 into a retirement account with a 9% interest rate compounded monthly, how long will it take until this single payment has grown in her account to $16,000? So, same idea, except for instead of saying how much will she have after so many years, they're telling us to find how long that will take, which means I'm looking for time, which means I should be able to take that formula and plug everything in the time and then solve that equation. So, I know I'm using the R over K formula because it's not continuously compounded, it's compounded monthly. And I'm just going to plug all my stuff in and then simplify it using a calculator and solve for it, all right? And again, be careful when you're doing this. My suggestion is use your calculator as little as possible till the very end, or if you are putting decimals throughout your problem, carry a lot of decimals over to the very end, but I really expect that we have about the same answer at the end of this. So, she's ending with $16,000. She's starting with $8,000. Her interest rate is 9%, so that's 0.09. And if it's compounded monthly, what is her K value? 12. And then I'm going to raise that to the 12t power, because I don't know what t is. And we can solve this without guess and check, without needing a graphing calculator, because we can just get this by itself. We can ln both sides and pull that out front, or log both sides, and solve this problem, hopefully the way that you did the other one. What? Divide 8,000 over? That's not going to do. Because you can't distribute 8,000 in here because of the 12t. Like, you have to divide that over. It's not an option. Also, if you want to go ahead and say, like, what is 1 plus 0.09 divided by 12, like, it actually is a terminating decimal. 1.0075, if that's easier than you writing that in your calculator every time, you can actually work it out. Questions on where I got this stuff from? Now I just want to solve this. if I have an exponent up here, the only way I can take it out is either to rewrite it using definition of logarithm like Grady suggested the other day. I just ln both sides, or you can log base 10 both sides. So every time I get to this point, I'm just going to ln both sides, because when I ln 1.0075 to the 12t, I know I can pull that 12t out front, and usually I just automatically pull it out front on my paper, because that's why I ln both sides. So I would have 12t times ln of 1.0075. And here's where you, again, you have options. You have to be really careful with your calculator. For me, to get t by itself, I know I'm going to divide by both of these. Do you agree with that statement?
Yeah.
If you want, divide by one and then divide by another, right? Like you can divide twice. I'm okay with that. If you divide all at once, be really careful and put it all on the bottom, okay? Because order of operations is multiply and divide from left to right. And if you don't put in parentheses, then your calculator is going to give you the wrong answer. So when I type this on my calculator, I'm going to type ln of 2, my parentheses is going to open and I'm going to close it. And then I'm going to put another parenthesis around before I type the 12. And it doesn't really matter if you don't close the end parenthesis, but if you did, you would have two parentheses at the end to close. Or just take ln of 2 divided by 12, hit enter, and then divide by ln of 1.0075 again. That should work also. Let's see if we get an answer that we agree with.
7.73.
7.73. Okay, so let's talk about this answer here for a minute. First of all, anybody need help getting 7.73? We need to round to the next time it's compounded. So this is the extra part, all right? This is compounded monthly. I want to know at what compounding will this happen. So this compounded monthly, you need to tell me at what month this is going to happen. 7 years and what would be the next month that would happen at?
7 years and 8 months. Yeah, 8 months.
If you took 0.73 in years, how can I change that to months?
It's about 3/4 of a year. It's about 9 months.
That's what I would do. But if it was like 0.4 maybe.
Oh, we're 0.4 into what's 9 months a year?
In 1 year, there are 12 months. Right? That's how you would do the conversion if you weren't just thinking how many months was it?
It's like chemistry stuff right there.
It is like chemistry. You get 8.76 months.
Oh, so we're almost through to...
So here's what you have to think about, okay? How is it compounding? It's compounding every month, so you need to give me the answer to the next month. If it happened at 8.76 months, do you agree we'd have to round up and say the 9th month is when it happened? I think so. So the answer you need to say here is 7 years, 9 months.
Oh, all right.
For me, Grady, I did exactly what you said. I said 0.73 is almost 3/4 of the year. It's going to be at 9 months is the next one. Think about those when you're doing them, okay? Let's do another one. They never end. It's so exciting. What interest rate compounded monthly is required for an $8,500 investment to triple in 5 years? So they like to give you problems about tripling your money or doubling your money. Sometimes they don't even tell you what you're starting with, because they just say how long would it take to triple your money, because it would just be 3 times what you start with. But this one they tell us what we start with. Compounded monthly means I'm using my same formula, right? If I start with $8,500 to triple my money, do you agree that I could just say that's 3 times $8,500?
Yep,
Or you could actually take 3 times $8,500.
25,500.
It doesn't even matter. Because when I divide 8,500 in R, I'm just going to get 3. What if they didn't tell me how much money it was? If you just called this P and they said we were gonna triple it, I could call that 3p, and then the 3's are gonna cancel out every time. So that's why they don't have to tell you how much money you start with to figure out how long it takes to triple it. Keep that in mind. But this one they tell you. Times 1 plus, what am I looking for on this one? Oh, the interest rate, which means this isn't even so bad to do. Maybe.
So you just have to be right on the top, that's fine.
So I don't know what R is, but I know it's monthly, so I know K is 12. And I know this is 12 times 5. Oh man, this is exciting stuff. Questions on where I'm getting that? Because number one, you have to know where to plug your numbers in. Then I'm just going to divide 8,500 over. And if I divide by 8,500, I'm going to get 3 equals 1 plus R over 12 to the 60th power. You want to FOIL that out 60 times? Me neither. No. Especially with R over 12, that'd be awful. 60 times. Yeah, so what did you say, Livio? Liviero? Root of 60. Can I just take the 60th root of both sides?
Yes.
That's exciting, right? Or the 60th root is the same as the 1/60th power, right? The 60th root of something is the same as taking that number to the 1/60th power. So it's whichever way you want to do on your calculator. You have a button that will let you take the root of anything. You have a button that will let you take the power to the 1/60th power. I don't care which way you do it. I'm not going to type in my calculator to the very end. If you type in your calculator now, write all the decimals down. So for me, I'm going to say, let's take the 60th root of both sides. And I'm going to get that the 60th root of 3 equals the 60th root of something to the 60th power is 1 plus R over 12, because it cancels that out, right? And again, I tend to wait till the end to use my calculator, so that's why I just wrote it like that. And then I just have to solve for R, so what would I do?
Subtract 1.
Yeah, I would subtract 1 and then multiply by 12, but as long as you multiply everything by 12, you can multiply by 12 first, because then you just subtract 12, no matter which way you do it. 60th root of 3 minus 1 would give me R over 12, and then I'm going to multiply by 12 at the end. And let's see if you did your decimal earlier if we get the same answer. I'm going to take 12 times the 60th root of 3 minus 1. We're looking at an interest rate here, so we should get a decimal, right? That makes sense. So I'm going to take 12 times... To do the 60th root, you have to hit 60 and then that button. And
What's that button?
the one above the caret, like here's the caret button. If you hit second and caret, it's this, right? The X root. So you have to hit 60 and then that. Or you can just do caret 1/60th power. .2217. That's your interest rate. So we could say that's 22.17% or 22.2 or however you rounded it from there. But
Wait.
that's
How did we
pretty
get
big.
to 22.7 again?
When I did this on my calculator,
Okay, I just want to make sure.
Did you get that in
That's
there?
a lot to do that. 22.
other questions on how I got that? Let's do one more. Ready? Stop, don't say well. Here's one. You need it? You forgot to subtract 4. Where's your minus 4? You didn't put parentheses at the end to show that the minus 1 is times 12 also.
But I did, and then it's just okay.
I think you did something wrong. Solving for t, kind of like the last one, we're talking about tripling, only now we're solving how much time is required for an investment to double in value if in interest is earned at the rate of 5.75% compounded quarterly. A lot of times they're solving for t because it's up in the exponent, which means you have to ln both sides. I don't know how much I'm investing, right?
Right.
But if I'm doubling p to double p, it would just become 2p, yes? Or if you wanted to make up a number, 500 and then double 500, no matter what you do when you divide that over, you should end up with 2 left. So don't freak out when they don't give you what p is. 1 plus, move back 2 places, so 0.0575, compounded quarterly, so what am I putting in there? 4 to the 4t power. And this is really just like the last one that we did, where you're going to divide p over, then you can ln both sides, and you're going to divide it over. It becomes very routine if you do these problems and actually work them out on your homework.
K is time that every year you get.
Yes, k is the... But quarterly means like it's...
Every 4 months or 3 times a year.
No, every 3 months. Because quarterly would be like 1/4 of 12, so it's every 3 months.
4 months.
Right. So it's, 4 times a year is what we're doing. So, I don't know, let's see if this makes sense to you. When I do these problems, I tend to not like to show a lot of work. And I automatically pull that 4t down and say that that's ln of 1 plus 0.0575 divided by 4. Syntax error, for the extra thing. 1.014375. And then again, if you feel like you're going to forget to put parentheses on the bottom and you're dividing by 2 things, just divide twice. Divide by 4, and then divide by the ln. Or divide by the ln, and then divide by 4. But I think that you should end up with ln of 2 divided by 4 ln of 1.014375. And you got to put all that on the bottom. We're looking for time here, so we should be able to have a reasonable answer. See if your answer makes any sense when you do it. ln of 2 divided by parenthesis 4 times ln 1.014375. Close my parentheses. I got 12.14 years. Oh my gosh, look at my son. I don't know homework. See the bars